Okay, so this is video 2 for day 5, volume using the washer method. So the one I'm going to have you try, it's bounded by these two functions, y equals negative x squared plus 2x plus 3, y equals negative x plus 3. So my suggestion first is to sketch it, figure out where the two functions intersect, because notice I didn't give you any other boundaries, and set up your integral to represent the volume. So hit pause and do those two things. Okay, so this is your picture. You have an upside down parabola, you have a line, they intersect at the point 0, 3 and 3, 0. So if you did set those equal to one another to figure out where they intersect when x equals 0 and x equals 3. Your larger of your two radii, since you're going to be rotating around the x-axis, will be the parabola, because the parabola is the function with the higher height between 0 and 3. And then the smaller of the two, which will be your lowercase r of x, is your negative x plus 3. So when you plug it into your integral, you have your capital R of x squared minus your lowercase r of x squared. So your larger radius minus your smaller radius. So now at this point, if it is just about the setup and you have your calculator, you can go ahead and do math 9, okay? And calculate your integral. I would say leave off the pi so you can at least have your fraction exact, especially if that's what the answer is looking for. Otherwise, what you have to do is you got to square that trinomial, you got to square that binomial, put your like terms together, and then integrate using your power up rule. So go ahead and pause this and take care of that. And you should get 108/5 pi units cubed. Okay, so moving on, the next one we're going to do, it is going to be rotated around the y-axis, so it'll be in the y direction. All right, the next set is going to be in the y direction, so you're going to see that the region is going to be revolving around the y-axis. The area that we're revolving around the y-axis is bounded by these three equations. So step 1 is to graph it. So go ahead and pause this and graph it. Okay, so here's our picture. And remember, we're going around the y-axis. So when looking at your larger radius, that's going to be this distance right here. So that's going to be your r of y. And your smaller radius, where you're going to be cutting out the volume of the hole, that's going to be this one right here. Okay, so this does need to be in terms of y instead of x, so that's going to be one of the first things we need to do here. Solve this for x. So I'm going to move my x squared over and subtract my y, and x equals the square root of 25 minus y. So that is your larger radius. Your smaller radius is the one in green, and that's just r of y equals 3. And remember, for your boundaries, when we do go to set up our volume, it's your lowest y to your highest y. So this is going to go from 0 to 4. You're going to have your capital R of y, so your larger of the two radii, squared, minus your smaller of your two radii squared, and we're in the direction of dy. Again, if this problem is just about the setup, at this point you can plug this into your calculator math 9. I would say don't do the pi. Figure out what your integral from 0 to 4 of that is, and then go ahead and throw in the pi. Otherwise, you're going to go through and this will end up being a polynomial where you'll just power up. So why don't you take a minute and calculate that volume. And you should end up getting 56 pi. So when I squared that and subtracted them, I got 16 minus y. So then you're just simply doing power up rule. And because it's from 0 to 4, all you have to do is plug in the 4. I'm going to give you one more to try on your own. It is going to go around the y-axis. If you feel like you're good to go, don't do it. If you feel like you need a little bit more practice with some explanation, you can go ahead and try it. Okay, so here's the problem you're going to go ahead and try on your own. And again, if you feel like you're good to go, then just go ahead and get started on the rest of the day. So this is around the y-axis again. There are 3 equations here. That's going to give you your shaded region, and you're going to rotate that region around your y-axis. So step 1, draw a picture. Okay, so here is your picture. So you have the 3 graphs, they all intersect, and so it is important to know this because we do need to know that ordered pair and this ordered pair, because we do need to know the lowest y value as well as the highest y value. Actually, we do know the y value. It is -7, but we do need to know this down here so we know the lowest y value. So what you want to do is figure out when x equals 1, what is our output there, and it is -15, because that will be important when setting up your integral. Again, your larger radius is from here to here, so that would be your r of y. Your smaller of your 2 is from here to here, and that's your lowercase r of y. Go ahead and set up your integral. So this is your setup, your larger of your 2 radii. You do have to take this up here and solve that for x. So x equals the square root of y plus 16. And then your smaller, the one in green, is just 1. So again, at this point, if it's just about the setup and you're not needing to show the work of the integration part, you can just plug that into your calculator, Math 9. Otherwise, you can integrate this by doing your power up rule once you square both of those. And for this, you should end up getting 32 pi.